Hello, everyone. My name is Daina Bouquin. I'm the head librarian at the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts. And I'm glad to have the opportunity to share with you today some information about a technology that my team has been developing in collaboration with the SmallSat community called MetaSat. Now, what is MetaSat? MetaSat's a toolkit. So this is kind of a name that we've given to the project because it has many pieces. So I'm going to talk through all of those pieces, but fundamentally what we've created here is metadata to help small satellite communities share information and learn from each other about their missions and about their work. So just to kind of break down the jargon a little bit, I thought I'd at least explain what I mean by metadata. To start, lots of people think of metadata as just data about data if they've heard the term at all. But really metadata is a term that's kind of a catch-all to describe lots of different mechanisms, tools, and approaches to modeling relationships between information gathered from contextual sources. So in my profession, we call this your provenantial sources, so the places where you get all this context. But what we're going to do is we're going to model all of the relationships between all of this context so that we can actually develop meaning. So without metadata, it's really difficult, if not impossible, to actually represent what something means. So you can, for instance, describe a box, and I can say that it's yellow, and I can give its dimensions, but I can't really necessarily give it any meaning without giving it context. So without saying where I got it and what's inside of it and why it matters. So metadata is very important for being able to kind of articulate anything effectively. And I think sometimes with metadata, it's easy to start thinking about, I guess, the meaning that you assign the thing being the absolute meaning. So if you wanted to describe that box and give it more representation and give it more than a physical description, say what it means to you by giving it all of this context. It's easy to forget that all of these things change over time, meaning changes over time. So I have an example up here of an object that's in my collection at the Center for Astrophysics. And this is just an image of a daguerreotype. Taken in 1849, it was the earliest image captured of the moon. So it used to be the earliest, it was the only image captured of the moon, because everything that is the first is at some point the only thing that it is. And at the time, this was a technological innovation that started an entire scientific revolution. So if you think about what was astronomy and astrophysics before photography, it was individuals looking through telescopes. And so the way that this object kind of instigated new science and opened doors is pretty profound. But last year, actually a few years ago, I loaned this to the Metropolitan Museum of Art, actually for an exhibit that they were doing on the history of photography and the moon to celebrate the 50th anniversary of the moon landing. So although at the time that this object was created, it meant one thing. Now it means something very different. And so we've added a lot more meaning to it, and our understanding of what innovation is has changed over time. So we have to add more context. I have another example here of a kind of an object that might not have necessarily been seen as important at the time. But so these are Galileo's really, really messy notes. And so at the time, Galileo certainly didn't necessarily know that his work would be important, but now we see this as the origin of the scientific method, the birth of observational astronomy, the start of a profoundly different understanding of how the Earth is situated within the universe. And so I guess this is to say that when we have objects and we have metadata that we assign to it, not only does it change over time, but we don't necessarily get to identify the things that are important ahead of time. So Some things get handed down serendipitously. We slowly identify them as important, and we're able to add more context to those things that are important so that they're able to be persistently maintained because we understand what they mean. So metadata is sort of how we maintain legacies and the ability for new meaning to be added to objects. And so I guess to summarize, meaning is just collective agreement about a specific thing at a specific time. So it's not static, and it needs to change so that we can add new context. And this is true with satellite missions. So I have up here just a screenshot of a paper about the mission series, a small satellite mission. And you can see there's a whole lot of metadata in this abstract. There's a whole lot of information about the series mission, but all of this metadata is purely just human readable. And we operate now in a landscape where having only human readable metadata is not really going to meet the needs we have for information sharing. So we agree, if we can agree that the metadata is important, but only people can read it and machines can't, that's quite difficult. So you can have lots of different ways even too that human readable metadata is aggregated. So here's a screenshot from a totally different directory saying some of the same information, but saying it quite differently. And so if I wanted to be able to search to Google and say, find me the series mission, not only is the name ambiguous, it would be difficult to be confident that you're finding information about the same mission across different sources. And you certainly wouldn't be able to search granularly through that metadata to try to figure out, for instance, how might I compare this mission to another mission? Or if I wanted to just know the launch mass of the spacecraft, I might be able to read that here, but it's not something that's going to pop up in the Google little knowledge panel that can kind of tell me that information. You know, when you search things and Google actually gives you an answer. That's not magic, it's just metadata. And the world we're operating in with SmallSats, all of this really important metadata and all of this important context is kind of floating around in lots and lots of different formats and lots of structures that are primarily human readable. And so what we're doing with MetaSat is trying to develop tools that kind of translate that human readable metadata into what I'm showing on the screen, which is structured semantic data that can be read by machines. So this is a kind of a portion of an example of a JSONLD file, which I'll say a little more about in a moment. But you can see that this is certainly something that you could teach a computer to parse and to start making sense of. So in the end, MetaSat is a toolkit that we hope will help SmallSat teams make their metadata more useful. And it has three primary components. The most important and most, I think, substantial portion is the MetaSat vocabulary. So basically, we're taking the language that you use to describe SmallSat missions. We're breaking that language down into concepts, so almost like terms, if you think of it just as terms. And each of those terms is given a unique machine actionable identifier to enable search engine optimization, federated search across APIs. It's a way to really disambiguate your concepts. For instance, because the context matters. So I was in a meeting once where I was visiting an observatory. I was given a visitor's name badge that said non-observer on it. So to kind of designate that I'm not someone who's going to be observing using the instruments. But in another context, non-observer could mean I'm not an observant person. So this is a way for us to really clearly disambiguate what we mean, what we're talking about, the terms we are using and why. And so this is a much more flexible way to define a vocabulary. So for example, thermal noise, we have here a description, an example, some synonyms, and I've underlined here the URI. So this is our identifier for thermal noise. It's just a URL in this context. And And so the vocabulary that we've made is not hierarchical. So we have grouped concepts together into structures that we hope are useful. For instance, we have groups of concepts or terms that are associated with different segments, for instance, a ground segment or the space segment, and families, which we think are useful for describing, say, a particular subsystem, like your thermal control subsystem or your attitude control subsystem. We have sort of recommended batches of words you could use to describe your mission. So for instance, with thermal noise, we have said that this is a concept that kind of fits on the space segment and the ground segment. It's also something that comes up in the context of thermal control and maybe your electrical subsystem. And we've given you the ability to suggest changes too. So with any of the concepts that we've written, we hope that we're able to get feedback continually from the community to refine what we mean here. But the second component of MetaSat is actually a bunch of examples. So that screenshot I showed with the breakdown of the metadata in that machine actionable structure, we've written a lot of example files to give recommendations for how you might be able to take the vocabulary that we've made and use that to represent your mission and your team's work and all of the things that give it context so that you're not starting from scratch and trying to make like a file like this to represent your work. So we have a whole set of examples. So for instance, this is a simple example. This is, again, it's just a chunk because it's hard to show screenshots here. Describing a few subsystems associated with a mission called Picard. So instead of just having human readable chunks of text, you could basically be pointing out to information from lots of different sources, and you're going to be incorporating it into a file that can be parsed much more systematically. The last component of what we've created is a set of crosswalks. So another thing that's really useful about the metadata toolkit that we've created is that it enables you to essentially translate between different lexicons. So our word for thermal control is not necessarily going to be the same as, say, the Chinese word for thermal control, or different vocabularies, other controlled vocabularies may also have slightly different terminology, but with crosswalks, we can give people tools to convert between syntaxes so that you're not necessarily having to come into full agreement about what to call something if you can say what the equivalencies are. So for instance, for our thermal noise, we have a crosswalk to wikidata. So wikidata is kind of a big part of how those knowledge panels in Google come up. So it's also how things are defined in Wikipedia. So thermal noise has an identifier that has Q1337490 is the Wikidata item for thermal noise. And you'll see that it's basically got the same definition, but when we are crosswalking to Wikidata, it means we're connecting up to all of the different synonyms for thermal noise, as well as the different translations in Spanish and traditional Chinese and Chinese. So the crosswalks, we hope, are really useful moving forward to making sure that you can actually translate between equivalencies from one vocabulary to another. And I also just kind of wanted to feature up here that MetaSat itself, so the vocabulary we've created, is represented on Wikipedia now. So that's kind of exciting. Hopefully you will get to the point pretty soon where the satellites that are satellite missions on Wikipedia are described using the MetaSat vocabulary. And also one of the things that's really nice about JSONLD and with crosswalks and everything that it accommodates, the format that we've optimized for anyway, JSONLD makes it so you don't have to always be using our vocabulary. So for instance, the example I have on the screen shows some instances where we're actually using another vocabulary that is not MetaSat. We're using concepts from schema.org. So I didn't have to kind of come up with a way to describe what an arc second is or anything like that. So we hope this is really flexible because it means you don't have to use MetaSat in isolation. You can combine it with other other metadata modeling tools. So I just wanted to kind of give a shout out at the end here to our early adopters and supporters. Like I said, we've been working with lots of people to try to make this as useful as possible to the community. The Libre Space Foundation is kind of our earliest adopters using MetaSat on their APIs and working with us to get the vocabulary up on the ground. We're starting to work with Pmpedia and the SSRI knowledge base along with the CIOS database. So ideally, we're operating in a world where there's APIs that will be able to help you search across these platforms, and that they will be using similar, if not the same, vocabularies to increase your ability to find what you need when you're searching. And I think the last thing I just wanted to say is that metadata basically makes it so we don't lose context and lessons learned. Without more enriched metadata that's machine actionable, we're not really going to be able to ensure that we can learn from each other over time and that your work has value and a legacy. So our goal is to develop MetaSat such that it actually continues to support your work and your needs. And so getting your feedback and input on what we're building is really, really crucially important. So I just put a URL here. There's lots of ways that you can try to communicate with us and give feedback on what we've built and shape the direction of the whole toolkit. So I'm happy to answer questions if anyone has any. Feel free to contact me, and thank you so much for your time.